using the imagination to control a real robotic arm and to drink a beer. The day Eric Sorto reached out to grab himself an ice-cold beer was a major step forward for brain science. Sorto is quadriplegic and has been unable to move his own limbs since a bullet wound severed his spinal cord 12 years ago. In the years since his injury, Sorto managed to attend college and write a gang prevention book, but one thing that frustrated the 34-year-old most of all was that he couldn't pick up a cold one and drink it at his own pace without having to ask a caregiver for help. "Drinking a beer by myself gives me hope that somehow in the future I can regain a lot more independence," he said. Sorto still can't move his own arms and legs, but after 2 years of hard and often frustrating work, he is able to use his thoughts to control a robotic arm. And he is able to do this with enough dexterity that he can now tell the arm to pick up a bottle of beer, bring it to his mouth, hold it there while he sips from a straw and set it down when he is done. The neuroengineering that made his achievement possible was described this week in the journal Science. The first time Sorto lifted the beer to his mouth, he was so exhilarated that he lost his concentration and dropped the bottle, spilling the beverage all over himself. Sorto wasn't the only one overjoyed by his beer-drinking feat. His excitement was shared by a cadre of scientists and engineers who wanted to know whether he could get a robotic arm to take instructions from a part of the brain called the posterior parietal cortex. So far, most of the work in the field known as neuroprosthetics has been focused on the region of the brain called the motor cortex, an area that fires off directions to our muscles when we walk, type on a keyboard or take a sip of water. A related prosthetic hand with feeling, recreating the brain-hand connection. Science Now. Prosthetic hand with feeling, recreating the brain-hand connection. See all related. 8. The posterior parietal cortex, on the other hand, is involved in the planning of those actions. For example, the PPC does not execute the individual finger movements that allow us to type "hello," but it tells the motor cortex that typing "hello" is our intent. It's one step further removed from the muscles, said Tyson Aflalo, a biological engineer at Caltech who led the effort to get the robotic arm to communicate with the PPC. It performs a higher, more abstract function. Using the motor cortex to control a robotic arm often results in jerky movement because the subject has to think about each individual action. Move arm down, open hand, close hand, bring hand up.